Hi, welcome all. I am Muthulakshmi. I am working as an assistant professor in the Department of Computer Application, the Standard 5 Rocks Rajaratnam College for Women, Sivakasi. Today we are going to see architecture of the operating system. In this video lesson, first we see what is an operating system. Operating system is nothing but it is an interface between the hardware and the software. Let us see what are all the types of operating system, what are all the objectives of operating systems in today's world. The objectives of this video lessons are: define the operating system architectures and its core components, identify the four main types of OS architectures, and then explain the relationship between user space and kernel space and hardware layers. Describe the role of system calls in OS architecture. Let us see the objectives one by one. Before entering into the operating system, let us see a real-time example. I am taking the Android phone. In Android phone, we are using the OS as Android, and the Android detects if you are opening the YouTube app, it detects your touch and tells the CPU to start the YouTube app. To watch the video, the OS manage and interact the connection to stream the video. It uses the memory to buffer the video. It makes sure the audio and video plays together smoothly. While receiving the calls, the OS passes the YouTube and switches to the phone app. After the call ends, it allows you to resume to your video. Battery low alert. The OS monitors your battery and shows the warning message. It suggests battery saver mode to reduce the resource usage. For security and updates, the OS regularly checks the software updates. It also protects the app from unauthorized access using fingerprint, PIN and password. Whether it is a phone or laptop or ATM, the smart TV, the operating system works silently in the background to make everything run smoothly and securely. What is an operating system? Already we see it acts as an interface between user and the computer hardware, controlling the program execution, performing the task. The key functions of operating systems are file management, memory management, process management, input and output control, security and user interfaces. And this is the operating system architectures. It lies in the following layers, that is user application in the top layer. Below the user application, the system call interfaces. Below the system call, it contains the kernel space and the hardware layer. The architecture components are user space, where the user application runs, and then system call, it is an interface between user and the kernel space. The kernel space, the core OS components with privileged access. The hardware are the physical components managed by the operating system, like our keyboard, mouse, memory, all. And the types of operating system architectures are classified as following types. Monolithic architecture, all the components in kernel space. In layered architecture, the organized in hierarchical layers. Microkernel architecture, minimal kernel with the separate services. Hybrid architecture, a combination of different approaches. Each architecture has a distinct advantage and trade-offs. Depends upon our applications, we can choose our operating system. First we see monolithic architecture. In monolithic architecture, all the components run in the kernel space. The single large executable kernel is there, and then direct function calls between the components and high performance due to no overhead. In this kernel operating system, we can directly make a system call with the core space. It is organized as file system, memory manager, process scheduler, device driver, and the last work is network stack. The advantages are the file execution, no inter-process communication overhead, simple design and implementation, easy to optimize. The disadvantages are poor fault isolation, default to maintain and extend, and security affect the entire system. Security vulnerabilities means we directly access the system call. So there is less security compared to the hybrid model. In layered architecture, the design principle is the OS is organized as a separate layer. Here we see the layers are organized as User program, system call, interface, file system, memory management, process management, device driver and hardware. Here each interfaces communicate with the lower layer frequently and also with the upper layers. The advantages are modularity and maintainability, easy to debug and test, and the disadvantages are the performance overhead due to layer transition, the difficulty in defining appropriate layers, rigid structures. Next we see the microkernel architecture. The core architect is mainly based on the essential services, while other services are run as a user space process. The file server and the device driver communicate with the microkernel, that is PC scheduling. Then memory server and the network server are away from the microkernel. The kernel service is minimal. In inter-process communication, that is IPC communications, basic process and thread management, low-level memory management and basic I/O and interrupt handling. Then in user space services, it use file systems, device drivers, network protocol and GUI subsystems. So it split the user space into the kernel space. So it enhance the processing speed of the operating system architecture. Next, microkernel, the pros and cons are: it is highly reliable, security and flexibility, portability and scalability. But if you take the disadvantages compared to other architecture, the performance, complexity and resource usage, design challenges are the disadvantages of microkernels. Example: Mac, L4 families, etc. In hybrid architecture, if we combine the different types of architecture, typically in the microkernel, the principles with the monolithic performance optimization. In every architecture, we have some advantages and disadvantages. So in hybrid architecture, we take some advantages from each architecture and build our own architecture. Here we organized it in the following layers: user application, system call interface, kernel space, and then core services and critical drivers, user space, non-critical services and hardware layer. It follows the same key features: the core services in kernel space for performance, non-critical services in user space reliability, flexible service placement, and then balanced approach to the performance maintainability. Example: in Windows NT, Mac OS and BOS, we all use the hybrid architecture. And this is the comparison for our architecture. Different architecture depends on the performance, reliability, maintainability and security and complexity. In monolithic, the performance is excellent and the layer is good, and microkernel is moderate, but hybrid is good. But in reliability, if you take monolithic, it's very pure, and the layer is good, excellent, and hybrid is good. And security, we get a poor security in monolithic, as we know directly it calls the system calls. In layer it's good, but it is excellent in microkernel. Complexity, if you want less complexity, we can choose the monolithic or some other layer. If you build complex, but it is more powerful operating system when compared to the other architecture, we go to the microkernel. Example for monolithic is Linux, MS-DOS, etc. And then layer we use VNS. In microkernel we use QNX. In hybrid we use it based on Windows and Mac OS. The modern operating system depends upon the current development. Each their application is different from others. So nothing is based on the architecture. Depends upon our architecture, we can select our appropriate architecture. For centralization, OS level virtualization, we can choose Docker and Kubernetes. We use core centralization. So for that we can choose microkernels. For real-time operating system, it is deterministic and response time. For that we can choose processing speed operating system. For mobile user, power efficient and touch optimized. So for that we can use a hybrid operating system. Cloud native OS, is designed for distributed operating system. So based upon our needs, we can choose our architecture. The emerging paradigm are serviceless computing, edge computing, quantum OS and AI integrated OS. These are the emerging paradigm in operating system. And then finally I conclude the key takes from this video lesson. The OS architecture directly impacts the system performance, reliability and maintainability. No single architecture is perfect for each and has a trade-offs. The modern system often use the hybrid approaches, and the architecture choose depends upon the specific requirement and constraint. For our application, we can select the criteria based upon our performance requirements, reliability needs, security concern, maintainability and resource constraints. So based upon our needs, we can select our operating system for our applications. Next, I have given some assignment questions for you for your exam preparations. If you want, you can use it. Finally, I say operating system is a software that is an interface between user and computer hardware, and the key functions are process management, memory management, file system management and user interface. So depends upon our application, we can select the operating system suitable for our application. If you want a high speed operating system, we can choose a hybrid mode architecture. Thank you.